the strongest unit that boosts up your capability. In this video, we're going to deal with an analytical pyrolyzer for laboratory use. To fully understand what a pyrolyzer is, there are essential terms you need to learn as prior knowledge. Pyrolysis. Pyrolysis is coined from Greek-derived elements pyro and lysis. Pyro means fire, and lysis means separating. So literally speaking, pyrolysis means separation by fire. In the pyrolysis process, the sample, typically very high molecular weight compounds, is heated at a very high temperature in the absence of oxygen, and it breaks down the sample into smaller fragments. This is a chemical process, and it is also called thermal degradation. In this process, these smaller molecules generated by thermal degradation are called pyrolysate, and the chromatogram of these pyrolysates generated by pyrolysis is called a pyrogram. There are several advantages that a pyrolyzer provides greater than other techniques. First of all, a pyrolyzer can be applied to a wide range of organic materials. Most of the materials exist in various phases depending on their properties, like molecular weight. Chromatography, as one of the analytical techniques, is categorized into LC and GC, and the molecular weight coverage of these techniques is shown like this. A pyrolysis, coupling with gas chromatography, can analyze most of the substances not limited in their molecular weight. Using pyrolysis, minimal or no sample preparation is required. You only need a small amount of the sample itself to put in a sample tube. Simply dropping the tube into a pyrolyzer, you'll get the analysis results by the GC or GC-MS run. Through the pyrolysis process, you can obtain various types of information, such as the most significant composition and structure of the polymer, quantitative information, and spectral data for polymer identification. According to the operating parameters, such as the heating rate or column type, pyrolysis can be classified into three methods, which are EGA, evolved gas analysis, TD, thermal desorption, and flash pyrolysis. Let's see what EGA is first. This is a pyrolyzer combined with GC-MS. When the sample tube is dropped into a chamber, the sample is gradually heated to a high temperature. The evolved gases from the sample are separated by temperature. The components that are off-gassed or evolved from the sample are then examined. This method doesn't require a separation column, but a retention gap, also known as a EGA tube. Scanning the sample by a heating temperature rate, it gives valuable information to identify the temperature range for the desired component. The next method is TD, thermal desorption. When you apply TD in pyrolysis, the sample is heated to a relatively low temperature, up to 350 degrees Celsius, to determine additives, residual solvents, or off-gassed components, not the polymer identification. So, the vaporized components in TD temperature range are loaded to the GC and separated in a separation column. This method gives chromatographic information by its chromatogram. Separating volatile compounds from the polymer, it can make the identification easy. The final method we're looking through is flash pyrolysis. When the sample is dropped into a chamber, the filament reaches a single high temperature, normally higher than 500 degrees Celsius, with a rapid heating rate over 1000 Celsius per second. Then, the samples are broken into smaller molecules at the set temperature altogether. The broken small molecules are introduced to a GC and separated in a separation column. The resulted pyrogram represents a fingerprint of the original sample for characterization. Utilizing formally described pyrolysis methods, a pyrolyzer can provide various pyrolysis types to optimize numerous application results. These are mainly used pyrolysis types, which are single-step pyrolysis, double-step pyrolysis, evolved gas analysis, and multi-step pyrolysis. Single-step pyrolysis is a single run of flash pyrolysis to characterize the original sample. Double-step pyrolysis is a combination of two methods. The first run is done at a low temperature as a thermal desorption step to separate volatile compounds from the polymer. Then the flash pyrolysis step is done to break down the sample at a high temperature. The EGA, evolved gas analysis, is also known as a fast screening technique by gradually heating the sample. This is to identify the temperature range for the desired components. Multi-step pyrolysis runs pyrolysis methods in a sample of more than two by applying an individual temperature setting for each pyrolysis in each GC run. EGA method is applied to determine the elution temperature. After specifying each temperature zone, the flash pyrolysis is individually applied to a specific set temperature in each GC run. This pyrolysis type is useful for the analysis of a highly complex matrix. You can also selectively get the results of the desired range of components, like the heart cut technique. Then what would be the most important in pyrolysis? The pyrolysis methods need to reach a very high temperature. It is required rapid temperature heating and cooling to improve productivity. Also, accurate and precise temperature control is essential because the pyrolysis results strongly depend on the experimental condition. This will ensure the accurate thermal profile for the sample to break down into smaller fragments with reproducible thermal degradation. Young & Chromas provides CDS 6000 series pyrolyzer with an optimized solution for each application. Let's see why choose 6000 series pyrolyzer. 6000 series pyrolyzer ensures various features as shown like this. It's easy to load a sample with a disc tube. It guarantees unparalleled reproducibility and superior resolution. It allows you easy maintenance and utilization of versatile accessories. And it provides a cost-effective, powerful library for the identification of polymer and additives. Let's look into the disc. The 6000 series pyrolyzer is equipped with a novel drop-in sample chamber disc as a standard configuration. When coupled with the disc sample tube, you can load the sample itself as solid or liquid, and the sample preparation process no longer requires quartz wool. Thus, the sample loading is as easy as dropping a tube into a chamber. The precision bore platinum coil, calibrated with sample temperature accuracy at plus or minus 0.1 degrees Celsius, ensures unparalleled reproducibility and superior resolution for a precisely controlled thermal profile. Easy maintenance. The 6000 series pyrolyzer is designed with quick access panels for easy diagnosis and quick exchange of parts to minimize instrument downtime. The self-diagnosis capabilities identify the leaking zones when attempting to troubleshoot the system shown on the intuitive UI of the software. Versatile accessories available. The 6200 comes with a multi-purpose rail mount to allow easy mounting of optional accessory modules, such as the auto sampler module, dynamic headspace module, thermal desorption module, manual probe, cryo trap, heart cutting and vent-free adapter, etc. Powerful library. The CDS library has more than 500 industrial standard polymers and over 500 polymer additives. This powerful library is available with cost-effectiveness and helps to address the need to identify unknown compounds from pyrolysis. When you run a sample through your GC-MS, you simply average the complete TIC spectra and then compare it to the polymer library. And you can add your own standards to the library. You will have access to free library upgrades for the life of your instrument. Pyrolysis GC-MS can be applied to the research and development of new materials, quality control, characterization, etc. The industry field to apply this technique is tons of out there, such as product evaluation, medicine, biology, and biotechnology, geology, airspace, and environmental analysis, to forensic purposes or conservation and restoration of cultural heritage. These applications cover analysis and identification of polymers, copolymers, and additives in components of automobiles, microplastics, tires, half-finished products for electronics, paints, or varnishes. You can experience this efficient pyrolyzer with cost saving while assuring all of these features and effective pyrolysis methods. Meet at Crozen Pi GCMS. You'll get the real plug-and-play solution in any application with efficiency.